Welcome back to R for Economics. This time we'll be talking about binary variables. So we need to install the package margins. And run the library. This will be used later. We're going to bring our data set, which is empty cars. And as we can see, AM is actually a binary variable that ranges from 0 to 1. So it's zeros and ones. If I just write it out, you can see the zeros and ones all the way across. Now I want to predict AM using some of the other variables that are available to me in my data frame. Okay, I'm going to define my model that AM is a function of displacement, weight, horsepower, and miles per gallon. So now I've set my model as a character string. And now I can use a linear probability model, just LM, with my model and data, and I can get a fitted model. And you can see that dispersion, nothing seems to be really that significant except for maybe horsepower here. And I can get the summary of the marginal effects, which should be almost identical to the ones above, if not absolutely identical. And then the other thing we can do is we can plot this and say, well, how well does it fit the data? So I can choose which variable from my list of variables to put on the x-axis, and then I can have 0 and 1. Now remember, my data is bounded between 0 and 1, and this is a linear probability. As we can see, if the data gets too long, what's going to happen? Well, it's going to exceed 1. And if the data actually got too small, then we exceed 0. So one of the things we can do is use a Logit model, which applies the function logistic function, which looks like an S. And we can use the same model, empty cars, and tell it the binomial type model, binomial meaning ones and zeros. And then we're going to link it to the Logit as the preferred family type. So we run the model. We now have the variable. And we can see that, well, just about nothing is significant anymore. Horsepower was, but now it's not. We can get our marginal effects, and these marginal effects are actually fairly similar to what we got in the previous one. Now we can do our plot, and we can see that it is bound between 0 and 1, asymptotically to 1. So as miles per gallon gets really large, it'll definitely be 1. If miles per gallon is really small, then it'll end up being 0. 1 meaning that AM is 1. Another option is to use the Probit model. It will give you a warning saying that it's just using zeros and ones. We can fit our model similarly to the previous one. It doesn't have significance. One thing to note is that, well, what do these things mean? That's kind of covered in the other thing, that the interpretation becomes very difficult. Luckily, there's the margins command and the summary of the margins, which will revert it back to something which we can think of in terms of a linear model. And this is the average marginal effect. So the displacement is a small negative, weight is a reasonably large negative. And we can see that these things are not significant. So they're not bound by, so not significantly different from 0. This is not a very good model, but it's just to show you how this works. And then we can plot that one, and we can plot this against weight, or we could plot this against horsepower, or let's do horsepower. We can see that we're bounded between 0 and 1. And if we want to plot our actual data against this, we can see how well it stacks up. Well, down here, it's supposed to be zeros, and we have a lot of zeros on this side and zeros here. And this indicates how poorly we're doing with our estimation. If we look at some of the other ones, so if we did this for, let's say, miles per gallon and miles per gallon, we kind of get a little bit better plot on this side, a little bit better over here, but clearly there's some mixture in between. And this comes from the errors in the model. Okay, great. And we'll see you in the next video.